Today my video about the assignment 1. So first we import the fraction list into the from the Kendra dataset, and then we load the data into the training main train label, test image, test label. So for the first question is what are the dimension of training image? So this is 60,000 image, and each of them is 28 by 28 pixel. We have 60,000 train label. For test image, we have 10,000 test image, and each of them has 28 by 28 pixel, and we have 10,000 pixel as well. 10,000 test image as well. So for second question, what is the length of train label and test label? So for the train label is 60,000 and test label is 10,000. Sum of the train and test label. So I bring 10, first 10 for the train label and first 10 for the test label. So we have first 10 train label is 900, which means when we use the instruction is the, so we have this is the Aqua Boost, this is the t-shirt, this is the rest. And same for the test label. First 10 test label is number 9 is Anchor Boost, 2 is for pull over, 1 is for closure, etc. So to show the digital content of image number 5, we use bring training main and index file. So this is the digital content. Next one, we use the pilot library to show the pictures of the train index file in the train dataset. So pilot.em show training main index file. We use red color for more accurate. So we have the picture of the train dataset at index file. And then when we mapping with the data from the assignment instruction, we have the label for the train for the index file is 2, which means this is a picture of a pullover. Same thing here when we show the digital content of image thing, index 500 in the test dataset. We bring test image 500. We have the digital content. So when we use the pilot library, we can see this is the pictures of the testing index file. So when we bring the label and mapping with the information from the assignment instruction, we have picture of the pullover again. So second one, we import the model and layer from the Keras. So we have from Keras import model and layer. So first we build the model using the sequential model and call it my network. So my network equal model dot sequential. So first number 12, reshape the image from 28 by 25 to one column with 284 neurons. So for this step, so we accept the input layer is 28 by 28, and then we flatten to convert image from into 1D vector of size of 784. So number 13, we normalize the image by division, the image by 225. So by doing that, we have the more train more efficiency by keeping numbers small and consistent. And then for 14 and 15, we add 2 layers. The first layer with 512 neurons using ReLU, and then the second layer 128 neurons using ReLU. We use ReLU because we have the model learn deeper patterns. And then for number 16, when we add 10 neuron density layer into the using the softmax, so softmax have the model decide between multiple choice. It convert the convert output into possibility, ensure some layers convert the possibility that add up to 100, and the categorize with highest percentage in the model final choice. So for 18 and 17, we combine with two settings. With the option A, we have my network compile, optimize ADAM, lot bar, this one, and accuracy, and then we train the model. So after this, because it takes time to train the model, and then after that, we go down here, we can bring the accuracy up to model. But before doing that, option B, I have to rerun the model from 11 to 16 to make sure the model is refreshed and can be replaced. And then after running the option A, I have to make sure I run the evaluate model or testing model A. I can see the test accuracy and test loss. And then for the model B as well, after running the model B, I have to check the test accuracy and test loss. And sorry about my voice. And sorry, this takes a while to finish. So basically, after train the model, I have to rerun the model, and then I have to train the model using the option B to have the comparison between two models. So for option B, we combine using the categorical. So because the categorical require one hot encoding, so I have to define train label, categorize, and to categorize train label. And then this is the result I run before. So I have the test accuracy with ADAM is 91%, and then test final accuracy with IMB props is 92%. And then I have to bring the testing evaluate for model A after I do the test for model A. So we finish here. So we go down here, we can start. So the test accuracy is 91.11, test lot is 0.3%. So now I go back here, I rerun the model. So I refresh the model, so I can train the model with the option B. So while waiting, I can answer the question number 19. So compare between fraction mean and the mean. So basically, the MNIST is the data set with hash rate and digital just from 1 to 9, and with a very simple shape. But fraction MIST is the more challenging because it's either grayscale image up close item. It can be so in this data set we have 10 categorize, and the image is harder to identify. For example, code and bulldozer. With the picture, it looks similar. So that's why the accuracy for the fraction is less accurate, because the complex of the feature, like closed atom, it has more iteration pattern than digit. And then we have more class, lectures, t-shirt, has the to define compared to 3 and 8 with the MNIST. And then the model limitation is simple. And for the training data, is the fraction MNIST require more data and to generate than the other one. So after we have the test accurate, so for question 21, as this board we could not define if the is over 15 because we don't have data for training accuracy. So we can only confirm over 15 when the training accuracy is much higher than test accuracy. So we only have the test accuracy, we don't have the train accuracy. We don't have training loss. So that's why we cannot define is it over 15 or not. So almost finished. Okay. So after we finish train the model, option B, we can see the accurate. Right now the Adam is 91.45 and then the final accuracy of MS Pro is 98.45. Then we can go here. We can see the accurate test lot for the option B. So this is 86.93 and then test lot is 0.4. Okay, so that's everything for my assignment. Sorry about my voice. Thanks for listening.